All right, let's get started. So today we'll do a little bit of review. Then, so we've done a lot of things in SwiftUI now. So today we'll talk a little bit about architecture, and then we will do a version of our calculator in UIKit, slightly differently because I don't want to bore you by just building the exact same thing, and we'll learn a new communication pattern as we're doing the UIKit version. So UIKit tip calculator. And then, so I guess first we'll talk a little bit about architecture. Okay, any questions before we get going? Cool, all right. So yeah, let's review real quick what we did last time. So we talked about a new concept that allowed us to use the compiler to prevent us making programming mistakes when we were dealing with conversions from one type to another. So who remembers one of the big problems that we were able to avoid by having the compiler help us? So what kind of a programming mistake is the compiler helping us? What we saw last week with the tip calculator. So we were getting user input, and we were converting it to what? The user input. So as they're typing, what kind of a type are we getting as the user's typing into the text field? Say again. Anything.
Looking for doubles.
Doubles, yes, and as we're typing in, so anything, and so we were coming from a string, right? So it could have been anything. So we had string, and we wanted to go to double. And then, so yeah, in other languages, so yeah, what can go wrong if we're going from string to double? Say again? Type mismatch, yeah. So if we're typing in, so this is not a string, this is not a double. In most languages, this would not be a double. This, an empty string, probably wouldn't be a double. So yeah, there's whenever we're going from a really big set of possible inputs to a slightly smaller one, there's a way that we have to deal with all of the stuff that can. Yeah, how do we get from all of the strings to just the strings that represent valid doubles? So other languages, what did we see there? So if you're doing this conversion, maybe what does Java do? So if you take a string and turn it into a double and it doesn't work, does anyone know what Java does? I don't remember, so you can kind of say whatever. I'll believe you. What does Java do? Say again? So I'm hearing exception. Great. What does C++ do? I also don't remember 100%, so again, you can kind of say whatever if it sounds right. What are other options that maybe a language does? So we might end up with not a number or something like that. So if we're trying to convert, maybe we get not a number. Other languages, they might not alert us at all. Maybe we end up with something undefined, maybe nil, and then we're in big trouble if we're trying to do math with any of those. So what does Swift have? What were we able to? How was the compiler able to help us not make these mistakes? How would the compiler force us to make sure that we're not doing math with the letter A, or I think another language takes just the Unicode the number of the Unicode for a character and turns that into a value, maybe not strings, but integers. So yeah, lots of potential mistakes. But yeah, so what does Swift do? How does Swift prevent us from using input to do math with? Does anyone remember? If you don't remember the names of things that we covered, that's also totally fine. Yeah, so we create some sort of a container that can hold a number, or what is the other thing it can hold? Nothing, yeah, so either the number or nothing. So, and we called this an optional. So an optional can either hold, so it can hold nothing, and I'm going to put that in quotes here. What does it actually contain then? It contains nil in Swift, or it holds something. And in this case, if we are talking about an optional double, it would hold this something would be the double. So yeah, Swift is a type-safe language. So a value. So if you're declaring a variable or a constant, it has to hold something. We can't just have a double in there, and if something goes wrong, put nothing in there. So that doesn't work. So if we say we have a double, there's going to be a double there. If we say we have a string, there's going to be a string there. And then if we're dealing with uncertainty, we have to create a new type that resolves this uncertainty. So this new type is either of the two, nothing or it holds something. So it's a container. So that's the solid type that we're dealing with. So our variable is going to hold this optional container. And then there's either nothing in this container or there's something in there. Any questions here? Cool. And then if we wanted to do math with one of those weird container objects, what did we have to do? So if you're saying we have double containers, so double optionals, so these optionals that can hold a double, if we wanted to do math with those, what did we have to do? Yeah, so we had to some sort of an if check. Very good. So the word that we used for it was unwrapping. So and we're doing that in this fancy if statement. If we can unwrap this optional, if there's something in this container, then for the duration of this if block, we can do some math with it. So if this is still a little iffy in your minds. Maybe it's not quite clear what's the difference between having a container that can have nothing in it or a double, or just having the variable hold nothing or a double. Those are all very valid questions. Does anyone have that question? So does it make sense that we need this container and that we can't just have a variable that is nothing or double? So yeah, because we have this container, the compiler can know if we checked. So the compiler knows we're using this container, and then we can only do math with it if we check the inside. So the compiler can help us with that check. And why again do we want the compiler to help us? Who remembers that? So what's the alternative? So if we make a mistake. But when the compiler helps us, we can't build, right? So we can't even continue programming, really. What's the alternative? So if the compiler doesn't help us, what happens instead? Say it again? Runtime exception. Yeah, runtime error, runtime exception, very good. And so yeah, those are errors, mistakes that we make that would get shipped to the user. So whenever we can have the compiler help us not make mistakes, that is really great. And so this is a really deep philosophy that Swift has. So the last year and a half, there's been a lot of work being released in the new Swift language. So Swift just changed to Swift 6. I think if you're just creating a regular Swift project, it'll still use Swift 5.6. So you can change it to use Swift 6. And Swift 6 is all about a new kind of checking that the compiler will do for you, which is really nice. And it'll make extra sure that you're not making that you're not committing race condition programming mistakes. So there's some like really cool work going on there. It makes certain things a little bit more awkward once you turn that on, but then unless there's a mistake in the code that Apple wrote, or the people that created the Swift language, so then we won't make those race condition mistakes anymore. So there's a lot of work happening there, which is good. So whenever the compiler can help us, that's amazing. All right. So yeah, optionals, we'll see them all throughout the semester. They're going to become a really natural thing that you guys are going to be working with. And the concept of this thing that can hold nothing or something, or maybe 3 different kinds of things, we're going to develop that a little bit more. There's some really cool features that we can use that allow us to create our own optional type of types, which is really fun to do. But yeah, so we'll probably cover that next week. We'll see how far we get, or we'll start covering that next week. Okay, any other questions? The other things that we did were mostly just Swift UI things. So we actually built that calculator, and so we learned a new view component, a picker, and then yeah. So that was last week. Any other questions? Cool. Okay, so then let's do a little bit of, I'll just create a new recording for this one since it's different.